Hello and good morning. Welcome everybody to our Fright Talk webcast today. Today's webcast presented by the FCIA is on Fibre Channel SAN workloads. Today you're going to get a good overview of understanding the fingerprints of what make up typical Fibre Channel SAN workloads. And hopefully by the end you'll learn more about how to identify these and understand how they work. Our presenters today are myself, Mark Jones from Broadcom Tech Incorporated. I'm also in a leadership role with the Fibre Channel Industry Association. We also have Nishant Lodha from Marvell. Nishant is a storage networking technology strategist at Marvell with over 20 years of data center experience. He considers Barry as his role model, as he would say. And our next presenter is Barry Maskus. Barry being from HPE. Barry is an HPE Storage Networks technical consultant with over 40 years experience of product design and development. Okay, a little bit about the FCIA. You probably have heard of the Fibre Channel Industry Association. It's been around for over 25 years. In fact, last year we celebrated our 25th anniversary. The FCIA is a mutual benefit, nonprofit industry association made up of manufacturers, system integrators, developers, vendors, and all kinds of industry professionals and end users. And we're all about promoting the Fibre Channel standards, the technology, and to make people aware of all this and educate them on the benefits of Fibre Channel. Fibre Channel, of course, is used pervasively throughout most large data center networks and continues to be the transport of choice for connecting enterprise computing to storage. If you'd like to know more about Fibre Channel, please visit our website at fibrechannel.org. Okay, I'd like to pass it over to Nishant now. Nishant, over to you.
Hey, thank you, Mark, and welcome everybody. I think it's an interesting topic today on Fibre Channel workloads. I think many of us who are familiar with Fibre Channel understand that Fibre Channel as a technology, as a protocol, as an architecture is extremely popular for running business critical applications, be it running on native servers or in virtualized applications. I think today the plan is that me and Barry kind of dissect what it means in terms of business critical applications, what kind of workloads are we talking about, and how Fibre Channel SANs and the inherent and underlying technologies underneath it help deliver a highly available, high performance, reliable and low latency transport and network that allows customers to put their applications on Fibre Channel. So we'll start off by a quick introduction to kind of all the key tenets within Fibre Channel that make it applicable for business critical applications. We'll then quickly talk about the different kinds of enterprise workloads and how they map to Fibre Channel technologies. More specifically, we'll take a few minutes to talk about how most people go about characterizing Fibre Channel workloads. What are the different I/O fingerprints or I/O characteristics that define an enterprise workload and how they map to Fibre Channel characteristics. Then Barry will come in after I finish my conversation here with you guys to go deeper into the Fibre Channel stack and talk about the various technologies within Fibre Channel, whether it's buffer-to-buffer credits, virtual machine identifiers, analytics, to see how all of that package comes together to deliver the transport that business critical applications require to access their storage. With that, let's do a quick overview of the key tenets of Fibre Channel. Right, Fibre Channel as a protocol, as a standard. It's over 25 years ago where Fibre Channel became a standard, and from a standards perspective, it defines both the physical layer as well as the underlying infrastructure and protocols. And one of the few things within Fibre Channel that make it resilient and high performance is that Fibre Channel is a lossless, congestion-free mechanism. There is within the protocol and implemented by the different components like HPAs, switches, and storage arrays is a credit-based mechanism, which makes sure that the receiver of the I/O is ready and has enough space or memory or cycles to go accept upcoming I/O, hence making sure that the network is reliable. Not only that, Fibre Channel is a multi-purpose transport. Over years, it has transported SCSI and IP and FICON, and more recently, and we'll talk a little bit more in detail, Fibre Channel is evolving to become a transport for NVMe, which is the big revolution in storage all around us. Different topologies supported from point-to-point, connecting two units together to large to switch topologies, where a Fibre Channel switch is the mix, 200 plus ports, and eventually you could cascade multiple different such switches and topologies together to bring thousands and thousands of nodes and highly scalable Fibre Channel deployments. Fibre Channel technologies have been progressing well in terms of speeds and feeds. What started from 2 gig Fibre Channels today is steadily progressed into 8, 16, and 32 gig Fibre Channel products already shipping and out in the market. There is 64 gig products assuming soon to come, perhaps later this year. And 128 gig Fibre Channel standards are being kind of worked on. So very strong kind of roadmap of speeds and feeds. But a lot of people expect not just access to storage using Fibre Channel, they also expect resiliency and security. And there are within the Fibre Channel standard protocols and mechanisms like FCSP2 for encryption and authentication. There is port bindings, LUN maskings, and things that enable segregation of networks required for security. Right? And then to top it all, whenever Fibre Channel is deployed, you definitely see redundant components being used, which means multiple different paths to storage and no single points of failure, and all of that is then managed by different multi-pathing routines that run within operating systems. So with that kind of background on Fibre Channel, let's do a quick comparison. Right? Customers today have a lot of choices when it comes to their storage infrastructure, right? With Fibre Channel being one of them, and other alternatives could be IP-based storage, it could be iSCSI, NFS, there is a hyperconverged infrastructure or HCI, which have kind of recently been much talked about in our industry. And then there is definitely build your own software-defined storage mechanisms. And what we have tried to do here is kind of break down the different components that customers, especially in enterprise workloads, expect from their transport, like availability, scalability, performance, security, and things like that. And for all of these key kind of capabilities, you see that Fibre Channel storage, highly available, high performance, low latency, very scalable and extensible network, scaling to thousands and thousands of nodes, inherent security and network segregation. All of that makes Fibre Channel kind of one of the most popular and one of the most trusted storage area networks for business critical applications. We understand, and a lot of our customers understand, that acquisition and ownership cost of Fibre Channel SANs could be higher than other options, but at the end of the day, the cost delta brings in a tremendous value in terms of availability and performance for enterprise applications that rely on Fibre Channel storage and Fibre Channel transport to storage. We talked about the kind of Fibre Channel in the beginning as a kind of low latency transport and a low latency network, but let's look at a typical stack here. And in many ways, this comparison here on this diagram is similar to the chart in the previous slide, where You have in a typical kind of deployment, you have operating system. There's applications that run on top of that. There is the SCSI layer, which nowadays could be depicted by a NVMe layer within the operating system, and then there are different kind of transports and then underlying physical interfaces underneath them. If you look at the very left-hand side where Fibre Channel is depicted here, you will see that the way Fibre Channel is designed from a zero copy, from a fully offloaded transport protocol down to Fibre Channel HPAs, there is very, very little overhead of a Fibre Channel transport and stack as compared to many others. For example, iSCSI typically depends on a TCP/IP stack running within the host, and many others require kind of more components within the host operating system or even in storage arrays to help make that happen. But this is one of the reasons why Fibre Channel is not only a low latency transport, but it also has very low cost per I/O, which means very little CPU cycles are actually spent moving I/Os across the wire. And this is one of the big reasons because customers want to use their processing or their compute capabilities to run applications, not to move I/Os on the wire. And Fibre Channel does pretty well on that for some of the reasons we have talked about and some more that Barry will talk about as we come about. Now, like I promised, let's look at kind of the key Fibre Channel workloads. But before that, let's take a brief look at what are the different market drivers that have made the evolution of Fibre Channel in terms of speeds, functionalities, and all of that. Server virtualization is definitely a big thing. It's a big revolution, and I often talk about what server virtualization did to servers. NVMe and low latency storage is doing to Fibre Channel, bringing about a new paradigm of accessing storage, of making the right choices to access storage in terms of transport protocols. There's been significant growth in applications, processors, NVMe, higher speed buses, and the absolute need for security and encryption of data in flight required and driven by many kind of government regulations as well as occurrences of lost data. A lot of these things are driving applications like databases, high-density virtualization, big data, replication between storage arrays, replication between sites, backup and media servers. To choose a storage component which is critical and which is highly available and highly performant. And Fibre Channel delivers on all the key things that such applications expect from their underlying storage network. Now, when we look at storage I/O, let's see what are the three big things that matter to business critical applications when talking about expectations from storage. It's definitely performance, not just high performance, not just low latency, but consistent response times, right? And there are things in Fibre Channel, whether it's buffer to buffer credit, whether it's low latency stack, whether it is virtual machine identifications that deliver low latency and consistent performance that business critical applications expect from storage. There's definitely reliability. It's extremely important. Any loss of reliability can have a significant effect on business, on business processes, on lost customers. In fact, just the other day, somebody mentioned that in the average cost of a data center outage has risen to almost $1 million average per data center outage. So just imagine how critical reliability is for customers. And we'll talk more about kind of what brings reliability to Fibre Channel. It's the protocol, it's the way it is deployed, it's the best practices around it, and certainly reliability and availability go hand in hand. But it is also critical to understand that when characterizing storage and I/O, whether from a performance or reliability or availability perspective, there is a full stack between the application and the disk, right, on the far end of the wire. And it's imperative to understand that every component has a role in it, all the way from the application to the operating system to the processor, the bus, the fiber channel HPAs, switch, the cabling, the array, the cache, and storage. It's critical to understand that there is more than one component in the mix, and all of these components need to work seamlessly together to deliver on the expectations that applications in enterprises have from their storage. Um, uh, Talking a little bit more about I/O and measuring kind of performance or characterizing performance of applications, and this pretty much applies irrespective of what transport we are talking about. But at least my conversations here and my perspective here would be more relating to fiber channel, obviously, which are a throughput, right? So throughput is generally, it's easy to understand. We all understand it's bandwidth, it's the transfer rate. Typically, people kind of talk about that in megabytes, sometimes in gigabytes per second. And throughput is more relevant in terms of characterizing I/O when we are doing large sequential blocks of I/O. And while IOPS, on the other hand, is more about transactional performance, and typically you'll hear about people saying millions of IOPS or hundreds of thousands of IOPS. And it's more relevant when application workloads are, rather small block sizes, mostly random in nature. And then there is latency, and latency has had much more renewed focus in terms of measuring and characterizing I/O with the advent of Flash and PCIe-based Flash or NVMe. And what latency is, it's basically response time. It's typically measured in microseconds. And think of latency as how fast your IOs complete, or kind of what's the gap between your IOs. And it's very important for workloads which are highly sensitive to latency, highly sensitive to response times. But it's also important to understand that none of these metrics operate in isolation, right? The amount of IOPS that are happening on the wire, multiplied by, just to do a simple math, by the average size of the block is your throughput on the wire, right? And latency is, what's the gap between your IOs completing. But it's important to understand all of them are related. For example, right, once you have achieved your maximum IOPS or throughput capability of a given storage area network, and you continue to push more IO down from the application, you will see increased latency, right? Because IOs will spend a lot of time sitting in queues. So it's important to kind of characterize and understand what each one of these mean and how they are related when you're looking at overall kind of applications and how they perform over fiber channel. Different applications have different patterns of IO, and we all understand whether sequential or random. There is different size of IO operations. I'm going to talk a little bit more about the different size of IO operations, give you perspective from customer surveys that we have done, as well as other publicly available data. IOs can be of different access patterns. It could be reads, it could be writes, it could be a mix, and then different types of workloads. For example, transactional or OLTP workloads could have more reads versus writes, while others like backup and restore could have different access patterns. From a sequential or random, it used to be a conversation that we often had with customers and storage architects and SAN admins in the days when media was rotating. It's becoming less relevant today with Flash. But still, it's important to keep in mind. And there's definitely queue depth, which is the size of the queues within within your operating system, within how much is queued on a typical buffers on the switch or on the storage array. And it's important to understand how queue depth plays into especially latency and concurrent operations in a fiber channel SAN. This is the survey that I was talking about, and my apologies if some of this text is a little hard to read, but I'll help you walk through it. On the very left-hand side is the results of a wide-ranging survey that we had polled our Fibre Channel kind of customers on, and we asked them, hey, what are the different applications that you run, and what are the typical block sizes that you see? And it's a mix of customers, architects, and the results were not surprising, but still they provide excellent view into what is actually going on the Fibre Channel SAN. And we typically see that most Fibre Channel workloads or most business critical applications that rely on Fibre Channel are running at block sizes greater than 4 kilobytes. In fact, 5 out of 6 applications used 8 kilobyte block sizes. I know if you read collateral, if you read things on the internet, you'll often see people claiming 512 byte micro benchmarks of millions of IOPS. Take that with a grain of salt. While it does depict kind of the maximum capability of a device, that is not what you're going to get in real world. That is not what your applications use. So it's important to understand what block sizes matter to business critical applications that run on Fibre Channel. And the chart here on the right bottom is from a storage array vendor. And what they have done is over a large period of time, a lot of call home data has been used to kind of collect across multiple different products of theirs as to what are the typical block sizes that hit that storage array. And my apologies, once again, the chart is a little hard to read, but the different block sizes all the way from 4K onwards are kind of plotted on the chart, and the bars indicate what percentage of IOs were that, and the colors then indicate reads versus writes. But the net summary of this is that there is very, very little or minuscule amount of IOs hitting storage which are less than 4 kilobyte IOs. In fact, within the 4 or 8 and higher block sizes is over 95% of all reads happen within those large block sizes. And just between 4 kilobyte, 8 kilobyte, and trending to larger sizes is almost half or more of the typical IOs that arrive at a storage array's door. So once again, to reiterate here, most workloads are 8 kilobyte or larger, and all the typical enterprise applications over time has shifted to using larger block sizes versus smaller. Moving on, let's talk a little bit about IO fingerprints. And by fingerprints is an attempt by us to characterize what typical workloads look on a Fibre Channel SAN. So one category here is OLAP applications or business intelligence. You can call it data mining, data warehousing. These are applications who are looking at data and databases to find out trends, to find out a selective set of parameters within the database to kind of look at and derive heuristics from that. Generally, these workloads are highly read intensive, are typically done at large block sizes. Most of them are random, and especially table and range scans are more sequential in this case. And larger block sizes. While compare and contrast that to online transaction processing or OLTP workloads or transactional workloads, these are kind of workloads you are generating when you go access your bank's website or you go shop around. It's a lot of small IOs that hit the backend databases. Mostly reads IOs. The application is querying databases, and databases querying its underlying storage to read stored data. It's generally small block sizes, very random, and generally 8 kilobyte block sizes. But, server virtualization has changed the way we look at IO fingerprints, and virtualization has a blending effect on some of these things where IOs get merged up into a blender where what IO could have started out as sequential could become random. And so it's important to understand what virtualization brings to the picture. And then there's definitely the bursty challenges. It's Monday morning login problem, whether it's a busy shopping day for a customer and things like that. We talked about high availability, about how Fibre Channel SANs use multipathing software and multiple different paths to a storage array to go access using different paths, make sure things are reliable, multiple switches, multiple paths, multiple HBAs, and multipathing software that runs on top of that. The other big thing within Fibre Channel, and I think Barry will spend a little bit more time on this, is NVMe, which is transporting NVMe over Fibre Channel. Customers can leverage existing networks, existing Fibre Channel switches, and many of the existing Fibre Channel HBAs to run FC-NVMe and bring low latency into the picture. Barry will talk about FC-NVMe v2, which is the next version of FC-NVMe, which is nearing standardization. And this picture kind of depicts how compare and contrast Fibre Channel with FC-NVMe, where FC-NVMe transports natively NVMe across the wire as compared to traditional Fibre Channel, which transported SCSI across the wire, and NVMe is a low latency stack. That kind of and Fibre Channel transporting NVMe kind of marries the low latency transport with the low latency NVMe stack. It's important to consider FC-NVMe for business critical applications as you deploy more and more flash in your infrastructure, and make sure that Fibre Channel has evolved to the new paradigm of storage, which is NVMe. With that said, I will pass it on to Barry, and I think Barry will double click on some of the things that I talked about and take you deeper into the Fibre Channel stack. Over to you, Barry.
Thank you, Nishant. I just want to pick up with some things that Nishant had mentioned. A very important aspect of this workload talk is that, workloads are quite varied. And although you can represent them by, static bar charts and, 8K is a norm, you can make all these references, but really in today's dynamic environment, workloads are unique to every customer, to every system, to every set of applications that are run. But it's not just one single thing anymore. Servers have become so powerful now. Big data is a nice word, but when you look underneath big data, there's many, many, many applications and workloads that work together to create the big data outcomes. As we said, virtualization is pervasive. But we all want to have a general understanding that what we're talking about when we talk about a workload is this combined I/O set or profile. And it's not a static thing, right? On a Tuesday, it may be different than it is on a Sunday night. So we just want to make sure that we understand that it's a very dynamic world. And Fibre Channel does a good job, and all of the Fibre Channel partners have done a good job in understanding this sort of multi-tiered workload platform. The idea today is that you're not just running one database on one server and one storage array. You may have an entire set of departments, everybody contributing and sharing their data across departments and across enterprises and across businesses. The world is dynamic. There are always new data coming in that has to get processed. There's always new applications. DevOps is a very pervasive technology today where you're constantly upgrading your services and quickly deploying them and mining the resulting data to add value, right? So it's a complicated world. It's a complicated stack, and it's not just a single stack. There are many, many apps running underneath, probably on the same server or the same cluster of servers, and sharing that storage and multi-tenancy is a mandatory feature today of shared storage. And we all understand that shared storage is very important to us because of the efficiency, right? With thin provisioning technologies, you know, it becomes very important for you to get the most value out of your storage. And if you know, take another approach where you distribute a few disks on every server and then, you know, deploy technologies to try to manage that data spread across a bunch of servers, your efficiencies are not anywhere near what you're going to get on a shared array that supports thin provisioning. So, you know, the fiber channel world, you know, loves to talk about shared storage. That doesn't mean you can't do distributed, you know, server level storage applications and back them up with, you know, shared storage arrays. It just, you know, the model is inclusive, and the fiber channel SAN technology allows it all to happen at the same time. I just wanted to give you an example of a big data workload. Now, this is all just open source and community supported applications that comprise a big data workload. The list is long, and it's constantly changing. It involves a lot of different partner companies' software that has to work together to create a big data solution. The point of this is that, you know, I can't just say, oh, 4K, 8K, you know, that's the workload. It's not that straightforward, right? And so what has come about, and because it's so important for this idea of getting value from your data, you know, we talk about the big V's of big data: volume, velocity, variety, veracity. This all culminates in the idea of a value proposition, right? So you need to collect the data, you need to have it accessible, you need to pre-process it, you need to post-process it, you need to keep it streaming so that you can keep up with current market trends and so that you can assess outcomes and make real-time decisions, right? So it's all about the V's today. And, you know, one of the big problems that has occurred, and it was so enticing, you know, to jump on to the, you know, the hybrid bandwagon and go off-prem and take advantage of what looked to be a simplification of the model and use someone else's data center and kind of, you know, not worry about on-prem as much. And, gee, what happened? Well, many critical applications started to understand that they couldn't really get the SLAs they required, right? There was a lot of con bullets that showed up, especially with that area of latency and response time, right? Especially when the data is rapidly changing. I understand it's a complicated choice, but what has happened is that you get forced to trade off agility, you know, going to the cloud, making it easy, versus your resiliency and your on-prem response times and control of that response time, right? So what we've started to see in the last couple of years is because, you know, the organizations were flying blind with regard to inconsistent latency at scale, right? They had this problem that they weren't really sure what tenants they were competing for the same, you know, other person's data center resources at any given time. So it became unpredictable, right? Latency could not be controlled directly. And so we want to get to the model of this idea of ideal sharing where the latency is predictable and consistent and constant, right? And I can understand on a Tuesday night or a Thursday morning what I'm going to see, right? As opposed to I don't know week to week, day to day, hour to hour what's going to happen. right? And so, yes, I am making a case for on-prem, but more importantly, what I'm trying to point out here is that you need the proper tools to profile your workload. It's multi-tenant, multi-tier, time-wise, plexing, whatever applications run at different times. The same workload in any one company is going to run differently, right? The infrastructure is slightly different, the software is slightly different, the revision of the software is different. So this ability, to profile your workload real time and make adjustments as needed has become essential, right? So today, unfortunately, the word telemetry has become a very key aspect of any modern data center. Even down to the HBA level and the storage LUN level and the VM level and the switch port level and the fabric level, right? Having telemetry data, and it's an interesting, quagmire here, right? We're doing big data, but we're also generating more data to understand how the big data behaves. And that is the telemetry aspect of SAN management. But fortunately today, there are cross-stack analytics, right? We can now, on modern traditional storage arrays and virtual machines and SAN fabrics, we can get a global view of what's happening. Where's the latency? Where are the critical resources? Where's the logjam? Right? We can get these sort of single screen views of the whole storage subsystem, ecosystem, and then we can drill down into these diagrams and we can start to profile, as I mentioned, a particular port, a particular VM, a particular workload that is causing some critical behavior. Right? So, and the other point I want to make is that Flash, it doesn't really change the requirements of a storage. Right? You still need the performance, the scalability, reliability. You need your disaster-proof recovery capability. You need replication. You need local and remote replication. You need your backups. You need to be able to integrate. Why not run a container on your storage array, right? Makes sense, right? If you need to pre-process some big data as it's coming in, why not deploy container? Containers today are not just limited to running on your server. Containers can actually run on switches. Containers can run on storage arrays. As I mentioned, the whole idea of drive efficiency, when you have distributed drives across all your servers, you're not going to have a very efficient data placement. You're not going to have algorithms fully optimizing that data placement across all those servers. Hence the argument for shared storage, where thin provisioning allows you to take advantage of the fact that many storage systems are over-provisioned. You need to have self-configuring, self-tuning, self-optimizing. And again, you need to federate systems, maybe around the world, across the US, wherever the need is to have that data locality. The important thing about flash latency is that it does provide a consistency as compared to rotating media. And, it's just wonderful today to see, with NVMe flash drives, that you can get, on a 4 million 4K IOPS workload, if that's part of your workload, you can see a constant 120 microsecond average latency. Constant, flat line, right? So this is becoming the norm today. And this is why there's so much interest in NVMe flash drives. Now, the model for flash drives really hasn't changed a lot, right? The value is there, the latency is there. You know, SAS connected NAND drives with 24 gig SAS are, you know, we're seeing some fairly stable latencies across the board. So what can give you that kick, right? You know, the media is about as fast as it's going to go. Oh, okay, so we'll grant that maybe the next generation is going to get, you know, the NAND down below 100 microseconds, maybe to 40 microseconds. But, you know, the other contributors, right, are the software stack and the actual controller, you know, and the transport, right? So, you know, those things contribute, and they're getting better and better. And this is the case for FC-NVMe, right, where you can transport in a shared SAN technology without having a large overhead contributing to that low latency media. You only have a fairly flat contribution as we move into this. But there's still this idea of a caching system that can be in that path that today provides you with that low latency experience, right? We call that storage optimized memory, and many modern traditional arrays are using that persistent memory as a cache to give you that experience without having the whole back end have to be revamped to go to NVMe flash. So, you know, storage continues to grow. The need for storage keeps growing. It's amazing the data collection that occurs. You know, I Google, you know, sweatpants, and the next thing I know, I'm getting advertisements for sweatpants, right? So we know that something's going on quickly, turning data into value. But one important thing that's happening in the storage growth, although there was this huge move to the cloud, 41% of businesses over the last year and a half have come back from the cloud. You know, so we in the Fibre Channel SAN business love to say welcome back. The reason is because on-prem is able to provide the cloud-like experience. It's understood technology, and Fibre Channel can underpin that and give you that control that was lost when folks went off-prem. So we want to profile our workloads. We want to make sure we have a good idea about the mix, the type, of course, the block size and the distribution. You know, randomness of the data placement. You know, we need to know about, is the data, you know, compressible? Can it be deduplicated? Is it, or is it not? You know, and all this will play in to your workload characteristic. Now, you don't get to learn all these things unless you have telemetry, right? And you don't get to learn these things if you use the telemetry data, you know, over a relevant time period, you know, over a work week, over a critical period that might occur on Thursday from 2 to 4, or, you know, so you can use the analytic engines and the telemetry data, you know, to come up with these profiles. And the interesting thing is, you can even extend those learned profiles, and you can start to do what-if scenarios. You can start to understand how you can address certain peaks that might occur in latency. You might learn how to mitigate problems before they occur proactively. You know, get insight in the causes of congestion. And I just, you know, want to mention that from an FC SAN perspective, the telemetry data has led to some very insightful feedback into the standards committee, where we are now trying to address in the standards certain behaviors that have been learned through telemetry data. And I'll get to that in a minute. So, you know, these analytic engines are critical. I encourage you to take a look at them. There's a number of tools that are available depending on your storage vendor and your SAN provider and your server provider and your virtualization environment. You know, there's integration work going across the entire infrastructure to give you the analytic view of the entire data center. So, you know, but we in the fiber channel standard business, we can really do what we can do to provide the correct telemetry data out of the SAN fabric itself, out of the HBAs, out of the storage array, based on SAN connectivity, fiber channel connectivity. You know, benchmarking has been around for a long time, and it can help. But as I pointed out, every customer's workload and environment and use of that workload and behavior of that workload differs. But you can get a sense of what a certain, underlying infrastructure is able to do, what a certain software stack is capable of. You can sort of get a, an uppercase idea of, what can be done. Like Nishant mentioned, I can peg the IOPS and kind of understand, well, that's the best I can do. But, these TPC workloads and data warehouse workloads, TPC DS and E and H, all are designed to help you get some metrics, some understanding before you actually build up certain data center workloads, right? But sometimes they're very expensive to stage and set up. Our friends at VMware, have provided the VM Mark III free. Comes in an OVA deployment. One of the interesting things about the VM Mark is that it has a tremendously random mix of I/O transfer sizes. So it's really a good test of what your storage array can deal with in terms of this idea of providing consistent response times. It's a great tool as you scale up the tiles. And spec is also a great tool if you want to do, sort of end-to-end profiling. I apologize for the slide there. Somehow the formatting got a little adjusted when we read it into BrightTalk. Another aspect of Fibre Channel is that there are so many virtual technologies now that, we all start off learning that Fibre Channel has two fundamental virtualizations. We have NPV and NPIV. Virtual machines today take great advantage of the NPIV capability. Although, in a sense, we've created a problem in Fibre Channel because, you can virtualize your Fibre Channel adapter, but it became a problem in sort of tracking that through the fabric. And so the standards committee came back and invented a technology called VMID that allows you to track a VM all the way from the source, through the fabric to the target itself. And our telemetry tools are now able to track, based on the VMID, how that VM is behaving, what it's contributing to, say, congestion or workload latency, etc. So there's a lot of virtualization, including vSANs. vSAN partitioning of a switch allows us to create the idea of multi-tenancy on a switch. We can use virtual SAN tagging in order to interconnect these virtual SANs to different topologies. We can then deploy NPV to allow, interoperability from devices who just want to proxy their services into the SAN. And we can also, virtualize the end port of every switch and do zone management to create partitions of different NPIV partition NICs. So, again, there's just a lot of virtualization going on from the hardware level up through, the whole software level. The whole case for NPIV is virtualization, database access. Multi-tenancy is a big value add for NPIV deployment, and containers. Containers can join in and use NPIV to create connectivity, virtual connectivity onto, a hard port that has been provisioned and zoned. So I just want to go down a little bit and talk about, how in the standards we worked very hard to bring VMID into the technology as a standardized capability. And it has proven to be very useful for, addressing this one basic problem, like, hey, why did I get this latency spike? Where is it coming from? How do I go figure it out, right? So, with telemetry data, we can now use the VMID as a tracking mechanism, and, we can traverse the whole solution, the whole workload, and we can actually profile the contributors to that spike, and then we can actually take steps, right? So it wasn't just, let's identify it. Hey, let's add QoS to the, the fiber channel fabric. Let's use these different VMIDs to create quality of service, to create capabilities across the fabric, right? And so today we have analytics for VMware environments where I can literally go in and click on that spike, and I can get a profile of who the contributors were to that spike, right? I can do a full assessment and breakdown of my VM environment at the storage array at the LUN level, and find out is there contention for the LUN? Is there some bursty write profile that's occurring? Is there some multi-tenancy aspect that's hurting that I could perhaps use QoS to address? So just stepping back a little bit, I think I've gone enough about telemetry. I hope you all agree that you should use telemetry tools today and take advantage of the information that's available. When we deploy SANs, we talk about three basic topologies, and most of our workloads can be deployed over any one of these three topologies. The thing about Fibre Channel is that you can scale these three fundamental topologies, right, and not lose sight of how to secure your data, or how to replicate your data, or how to interconnect multiple data centers, each one perhaps deploying these different topologies. How fabric shortest path routing works in this without creating loops and without creating, dead paths because of loop prevention technology, right? So, Fibre Channel technologies, whether they're just traditional AB fabric, or whether they're meshed, or whether they're, core edge for large distributed, high scale networks, use this basic algorithm for routing to optimize your path, to optimize your latency through the fabric. The most important thing that you can walk away from this presentation knowing is that, there's a foundational service that Fibre Channel has had for the last 20 years, and it's called a fabric controller, right? And there's a fabric controller protocol that allows the SAN to scale, that allows you to create login and discovery, that manages login and discovery and node-to-node discovery, right? And it does your principal switch and your domain assignments dynamically. right? And you can synchronize across fabrics worldwide if you have such distributed fabrics. You can merge or you can keep them separate, right? So we have virtualization technologies that allow SANs to remain local but have perhaps access to particular devices in a remote SAN. But there's not another technology out there today that gives you this sort of foundational fabric service, right? Now, this fabric service has been hardened over the last 20 years. It's, you know, it works at scale. It works worldwide fabric. It works across data centers, right? It works obviously from your, you know, your virtual server to your virtual drive, right? So it's a very key aspect of Fibre Channel. It's one of the things that, you know, we like to say, welcome back to Fibre Channel after your cloud experience. You get your fabric service controller back. You have that control. And it's a very important key tenet of Fibre Channel is fabric services. And I just, you know, want to emphasize, you know, the idea having a login server, having a name server, having a management server, being able to look at your SAN and who's in the SAN and who's operating, who gets to talk to who, you know, which initiator can discover which target. And it's, you know, it's even automated today where literally you just plug the cable in and you can auto zone and you can auto provision, right? So, you know, it's not just like this raw technology, right? It's refined. It's become automated. It's become easy to monitor through telemetry. And it's getting better. You know, and it has all these features that have grown up over the last 20 years for data availability, whether it's, you know, just synchronous or asynchronous remote copy, whether you use, you know, an IP protocol to replicate across very long distances, right? FCIP is a very stable, mature technology, and it works across, you know, very, very long distances. And then, you know, whether you want to build a metro cluster, right? So we have clustering technology that allow you, you know, to replicate, you know, within sort of, you know, the Manhattan to New Jersey type environment, you know. So, and it all depends on your recovery point objective, right? How critical is it? How critical is downtime? Nishant mentioned $1 million. You know, some customers just can't afford that kind of downtime. Right, so Fibre Channel brings this resiliency, this disaster recovery capability to, you know, the whole solution. I just want to end up here with a quick discussion here about, you know, where are you going to deploy your workload? You know, I just spent, you know, a half hour telling you how stable and mature Fibre Channel SAN is. FC-NVMe is there as well. With FC-NVMe 2, it's gotten even more robust, and I'll explain that in a minute. But we also take a look, and you know, I've been doing a lot of work with Rocky and RDMA and TCP NVMe, and you know, you can get 4 million IOPS at the click of a button, but you know, you have to understand that it's changing constantly. That you know, there's a new model to multipathing. You still have to worry about ECN and data center bridging. And, you know, I think some of you on the call will probably remember FCOE. And, you know, if I heard anything over the last 5 years, it was FCOE's hard to deploy, hard to scale, right? But, you know, Rocky, NVMe over Rocky, you know, is based on data center bridging as its lossless technology. It does depend on ECN as we get into V2, and it avoids some of the issues that occur with priority flow control as opposed to BB credit. And, you know, we've all had the iSCSI experience. It's great for small environments, but it doesn't scale. It's hard to manage. And fundamentally, Rocky and NVMe over Rocky, RDMA and TCP, they have to solve the auto provisioning problem. And there's proposals out there, Lightbits and other companies have their ideas and their proposals, but they're still evolving, very, very fluid. iSCSI is stable and mature, but it still doesn't have fabric service. Nobody really uses ISNS, and it doesn't really provide that security that you want in a SAN. But it's great for small topology. With Fibre Channel and T10 diff, you can get a fully, guaranteed end-to-end solution, across the whole stack. And you have to think about, where's T10 diff on RDMA, applications, right? So let's just keep that in mind. So I only have a minute left, I think, before I turn. I just want to mention NVMe 2. The whole purpose of NVMe 2 was to take care of errors below the protocol level. The standard has now been written. It's in public review. We think it's nearly done from a standards perspective, but it gives you even a more trusted approach and step forward to deploying FC-NVMe, right? It's going to give you that consistent latency experience even when there are errors, even when there are potentially frame drops. So keep an eye on this, right? We'll probably have a plug fest later this year to demonstrate this for y'all, and you can go and read the standard today if you want to learn about it. The other thing we're doing in the standards, we're moving beyond buffer-to-buffer credit. We've decided that we can do better than recovering dynamically credit loss. We can automate and take care of this problem of fabric congestion that can occur because of some greedy device holding on to the already and stalling the fabric because it can't consume the data quick enough. And so we're asking for help from the end devices. This is in document review. There's use a signaling method that has been added to the technology. So with that, I'll hand it back to Mark. I don't know that we have a lot of time for Q&A.
Yeah, we're
back to you, Mark.
Thank you so much. Okay, thank you so much, Barry. We are over time. So again, I want to thank our presenters, Barry and Nishant, for their content. It was just fantastic. Let me skip to some housekeeping information before we start losing people, and then we'll get back to the Q&A. We have a couple questions. Please, all you in attendance, please rate this event. Your feedback is critical for us and for the BrightTalk algorithm to promote our webcasts. We have historically received great feedback from those watching, and we'd like to continue to do so. So please, please rate this webcast. Also, we will post the Q&A blog on our Fibre Channel FCIA website, fibrechannel.org. We'll have the questions and answers we received today located there. Please follow us on Twitter. We're at FCIA News for all updates and future webcasts. And then we maintain all these webcasts in a library for on-demand viewing, so you can forward them to your colleagues or share them around as you like, or as in the case of this excellent webcast, you may want to go back and dive deep into each of these subjects because they're so fascinating. Some of the ones we have: Fibre Channel Fundamentals, FC-NVMe, Long Distance Fibre Channel, and so forth. Lots of good basic information all the way to advanced topics. So you can find those on fibrechannel.org/webcasts. We also are now putting these on our YouTube channel as well. Okay, our next webcast is coming up. We think in sometime at the end of March, early April. It's on the making of standards. So we ask you to keep. We don't have exact date and time yet, so keep following us on the Twitter channel, or also post this on the website. And here, if you're subscribed to our channel here, you'll get the notification about the exact date and time to register for this webcast. Okay, we do have a couple Q&A questions. One of those reads, and this I think was from Barry's section, why does a big data vendor like Cloudera recommend 12 Gbps SAS connected to direct attached storage array instead of using fiber channel based storage? Barry or Nishant, do you guys have any response to that?
So this is Nishant. I think I'm not exactly familiar with what Cloudera recommends, but I have personally seen big data deployments at customers who had originally started off by having a EBOF or a JBOF hanging off their nodes, and eventually migrated to fiber channel and saw better storage capacity utilization as well as performance. But I can't comment on a Cloudera specific strategy here.
Okay, great, Nishant. Yeah, that's like I said, that's a very specific question regarding Cloudera, and we'll probably have to research a little bit about where they're coming from for that, and we'll offer to put that on our Q&A that goes on the website later on.
That's fair.
Yeah, we have a second question here. Can we have a name of the telemetry software which can be used for analyzing and profiling the fiber channel fabric? Is it a specific vendor?
I'll take this one. Yeah, Mark, and thanks for asking the question. The FCIA tries to be vendor neutral, and I'm not trying to dodge the question, but I would love to go through a whole 1-hour pitch on HPE's technologies that address this question. If you would like to email me your question, I would be happy to give you information about how HPE has taken on that question and what we've done about it.
Thanks, Barry. That's a fair response. And probably to add, if you're aligned to any particular vendor, they want to do a search on their content to see if they offer anything, or feel free to, as Barry suggests, contact him. He's got a wealth of information there. Okay, so the link to the webcast again is fibrechannel.org/webcast. Please visit our website at fibrechannel.org for all information on these webcasts, on the Fibre Channel roadmap, and all sorts of information. With that, I would like to again thank our presenters, Nishant and Barry. Just fantastic information. And we thank our audience for attending. And again, please rate us on the BrightTalk rating system. Again, we'll conclude this webcast now. Thank you all for attending. Bye-bye.
Thank you so much, Mark, and thank you, everyone. Bye-bye. And thanks, Barry. Sorry.